Hello everyone, myself Mr. Mrugendra B. Poddar, working as an assistant professor, Department of Pharmaceutics at Sri Vile Parle Keloni Mandal, Institute of Pharmacy, Dhule. In this video, I am going to discuss about size separation. Disclaimer: this presentation is made for education purpose only and not meant for any commercial interest. The information provided in the presentation by presenter is taken from his own personal experience and understanding and from the references quoted at the end of presentation. Learning objectives. After completion of video, the student should able to learn about the objectives of size separation, applications of size separation, mechanism of size separation, how by which mechanism the actual size separations will take place, some official standard of powders as per the different pharmacopoeias, and some official standard of sieves as well as size separation. Introduction of size separation. Size separation is a process by which the particles are separated into fraction of known particle size. As we know, the pharmaceutical powders are polydisperse in nature, so we need to separate it as per the desirable particle size with the help of screen or with the help of sieves. So if the mixture of powders is there, like a mixture of coarse, moderately coarse, fine, etc. So we just separate the particle as per the sizes with the help of screen. That process, that unit operation is called as size separation. Size separation is a unit operation that involves the separation of mixture of various sizes of particles into two or more portions by means of screening surface. Size separation is also called as sieving, sifting, classifying or screening. Size separation is based on the physical difference between the particle size, shapes and density. The actual size separations will take place because of the particles are differed as per their sizes, they are differed as per the shape, as well as they are differed as per the density. Then and then the size separations will take place. There are some objectives of size separation. First, to determine the particle size and size distribution that is useful in the production of tablet and capsules. As we know, during the formulation of tablet and capsules, we required a uniform particle size. So to determine the exact particle size as per the grades of powder, we distribute the particles as per their sizes, which is usable for the production of tablet as well as capsule. Second, to test the efficiency of size reduction equipment or process. As we know, there are different mills used for size reductions like hammer mill, ball mill, fluid energy mill, etc. So as per that, we select the efficiency, we choose the efficiency of size reduction equipment as per the sizes of particles after size reductions, because most of the equipments will utilize or will connected with different classifiers like bag filter or cyclone separator or etc. So we know which one is more efficient for size reduction purposes. As we know, the fluid energy mill is more efficient than other mill for the purpose of size reduction. To optimize the process condition such as method of agitation, time of screening and feed rate. These are the objectives of application of size separation. First, uniform size particles undergoes less segregation. So as we know, most of the pharmaceutical powders are polydisperse in nature. So polydisperse will convert into mono-size particles by size separation method, which will cause less segregation. Filling of particles in capsule ensure more uniformity in weight and dose. Of course, after size separations will get mono-size particles, so uniform distributions or equal distributions of particles in capsules will take place for more uniformity in weight as well as in dose. Coarse granules with little fine powder ensured good flow ability. Fine powder are those which pass through mesh number 85, those for topical applications, and those pass through mesh number 60 will use for oral administration. So fine powders are decided as per the route of administration of drug. If it is used topically, then the particle size for fine powder is mesh number 85, and if it is used for oral administration, then the particle size is nothing but 60 mesh. So what indicates as mesh number 85? So how many number of apertures or openings present in particular area in specific sieve? The area is nothing but 1 inch. So 85 number of apertures present in area 1 inch. So it is called as sieve number 85. While if the number of aperture is 60 in 1 inch in specific area of that sieve, then it is called as sieve number 60. So those particles will pass from sieve number 85 called as fine particles for topical applications, and those particles will pass from sieve number 60 which is used for oral administration, considered as a fine powders. Mechanism of size separation. How the actual size separations will take place, by which method the actual size separations will take place as per their particle size. So the screening is the method of separating the particles according to the sizes. As we know, for particle size separations we require a screen or sieve. Then and then we just distribute the particles as per their sizes. The material that remains on the given screening surface is called as oversize or plus materials. Those particles which are not able to pass from particular sieves, which will retain as it is after screening, those particles which will retain as it is, that particle is called as oversized particles or plus particles. While those material will pass through the screening surface is called as undersize or minus material. It means those material will able to pass from sieves called as undersized particles or minus particles, and those which are retained on particular sieve is called as oversized particles. This process can be accelerated by inducing some type of motion to the particles. It is assisted by three mechanisms. The actual size separations will take place is due to the motion. So type of motions will take place or it will assist by three mechanisms. First is agitation, brushing and centrifugal force. So size separations will take place either because of agitations, because of brushing, or due to the centrifugal force. Size separations will take place. So these are the three mechanisms like agitation, brushing and centrifugal force. We'll discuss one by one. First is agitation. In another language, agitation is nothing but motions, or we can call it as movement. Sieves are agitated in number of ways. There are three main ways to agitate the sieves. First is oscillation, second is vibration, and third one is gyrations. So first is oscillation. Oscillation is nothing but the type of agitations. Due to the oscillations, either size separations will take place. So sieves is mounted in a frame that oscillate back and forth, that is reciprocal motion. The sieves are slightly inclined and the motion is parallel to the plane of sieves. So when we place a set of sieves, oscillations will take place. That is nothing but motions or movement of that particular sieves will takes place. Either it will oscillate back to forth positions. So due to that oscillation motion, due to that the exact size separations will take place. If you observe in diagram, red particles are separated from green, are separated from blue. Initially there is a mixture of powders, red, green and blue, but after oscillations or after agitations, after movement of that particular sieves, the exact size separations will take place as per the different sieves. Another type of agitation is vibration. Due to the vibration, exact size separations will take place. The sieves is vibrated at high speed by eccentric device, either electrically or mechanically. Rapid vibration helps the powder to pass through the sieves and prevent blinding of the sieves. If you see the diagram, there is a mixture of powder which contain different coloring particles are there. They are separated as per the particle size due to the vibrations. Here we are using a different set of sieves. First is coarse, then moderately coarse and fine, like that. We arrange a set of sieves as per ascending order, feed the powder material and go for vibrations. After vibration of sieves, just operate the sieves for some period of time. Then you will observe the particle size separations will take place. Black powder are separated from yellow, are separated from blue, are separated from red. So exact size separations will take place due to the vibrations. And third method of agitation is nothing but gyration. So gyration is nothing but again one of the motion type of movement, but it's a circular motions or spinning motions. So sieves are placed on the rubber mounting and connected to an eccentric flywheel. This gives the rotatory movement of small amplitude to the sieves, that in turns to provide the spinning motion to the particles, which helps to cross them through the sieves. So due to the rotatory movement of that particular sieves, spinning motions will take place. So due to that spinning motion, the exact size separations will take place. The particles are passed from the different number of sieves. So gyratory screen are box like equipments of either round and square in shape. Gyratory screen have auxiliary vibrations caused by balls bunching against the lower surface of the screen. See, if you observe the diagram again, there is a rounded shape or square shape is this. So due to the gyrations or due to the rotatory movement or spinning motions of that particular sieves, the exact size separations will take place, and again coarse are separated from fine particles due to the process of gyration. Agitation method are not continuous process, but it can be made continuous by inclination of the sieves. If we change the position, straight sieves will convert into inclined sieves, so it may be made continuous process. All three modes of agitations are used simultaneously for efficient size separation. The example of agitation is Rotex screen. There are some advantages of agitations, like agitation method are inexpensive, it's a simple method and rapid method, while some are disadvantages, like if the powder is not dry, the aperture become clogs and it will difficult for size separation if the powder is not dry or little bit wet in nature, so it will not easily pass from sieves, it will be blocked. Another disadvantage is during agitation the attrition occurs which cause the size reductions. When we go for vibrations or when we go for agitations, then the particles are interact with each other. Due to the shearing force, they will remove the edges of or corners of that particles, and that's why the size reductions will also takes place. So this is nothing but the disadvantages for agitation method. Another method of size separation or another mechanism of size separation is a brushing. Here the size are separated with the help of brush. Brush is used to move the particles on the surface of sieves and keep the meshes clear. In case of agitations, the rotations or movement or migrations or motions of sieves will take place. Here, the sieves are stable. Rotations will take place of what? Brush. Brush will rotate it. So brush is used to move the particles on the surface of sieves and keep the mesh clear. The brush is rotated in the middle in case of circular sieves. For example, rotary brush cleaning system. The light breaking of materials lumps is achieved due to the horizontal scraping and vertical crushing force on the product. This is used for separation of greasy or sticky powder such as waxes and soap. Basically, brushing method is used for during the separation of greasy and sticky powder, those having ability to bind or to clog the sieves. That's why brushing method is used for that kind of materials, basically for waxes and soaps. Another method of size separation is centrifugal method. So particle size separations will take place due to the centrifugal force. High speed rotor is fixed inside the vertical cylindrical sieves so that on rotation the particles are thrown outward by centrifugal force. Current of air can be generated by means of jet of air which help in separating the particles. For example, cyclone separator, air separator. These are the different separators which is used for particle size separation by using centrifugal force. Here they just create the centrifugal force and due to that the particles are thrown outward and the size separations will take place. There are some advantages of centrifugal methods. Centrifugal methods are extremely useful when conventional screening tends to block the sieves. If the particles having ability to block the sieves, some are sticky particles, so that time centrifugal methods is extremely useful. Again, it is extremely useful for the fine particles also. They are easily separated due to the less dense particles. Now we'll discuss about the official standards of powders. Powders are classified as per the grades which is mentioned as per the different pharmacopoeias. For measuring the size of powders, the degree of coarseness or fineness of powder is expressed with reference to the nominal mesh aperture size of sieves used. Indian Pharmacopoeia specified the different grades of powders and the sieves from which all particles must pass and the sieves through which not more than 40% of particle pass, the nominal mesh aperture size of the sieves also given. Basically, as per the Indian Pharmacopoeia, the powders are classified as into different grades like coarse particles, moderately coarse powder, moderately fine powder, fine powder and very fine powder. So powders are classified into different grades as per IP. So coarse powders having a particle size is 10 to 44 mesh, while moderately coarse particles 22 to 60 mesh, moderately fine powders 144 to 85 mesh, fine powders that is 85 mesh, and very fine powder that is 120 mesh. So how you can define the coarse powder? Coarse powders are nothing but those powders which are all particles are passed from sieve number 10 and retain on sieve number 44, but at least 60% will retain on sieve number 44, and there may be a chance to pass or not more than 40% particle will pass from sieve number 44. So that kind of particle is called as coarse powder. Coarse powder, all particles will pass from sieve number 10 and retain on 44, but there is some criteria. Either all 100% will retain, or maximum 60%, at least 60% will retain, or not more than 40% will pass from that sieve number 44. So that kind of powder is called as coarse powder. Same way, moderately coarse powder, that is particle size is 22 to 60, that is all particles will pass from sieve number 22 and retain on 60, not more than 40% will pass from sieve number 60. Moderately fine powders, that is sieve number 44 to 80, all particles will pass from sieve number 44 and retain on 85, but not more than 40% of particles will pass from sieve number 85. Same as fine powders. Fine powders are nothing but those powder which are passed from sieve number 85, and very fine powder are nothing but those powder which are easily passed from sieve number 120. So that particle is called as very fine powder. So these are nothing but the different grades of powder as per the Indian Pharmacopoeia. Now the grades of powders and sieve number along with nominal mesh aperture size as per IP will mention in that table. See, grades of powders, that is coarse powder, moderately coarse powder, moderately fine powder, and very fine powder. Here there is a mention the sieve through which all particle will pass. As I tell, see, coarse powder, all particles will pass from sieve number 10 and retain on 44, but again sieve through which not more than 40% particle will pass, that is 44. So 10 to 44 coarse powder, 22 to 60 moderately coarse powder, 44 to 85 moderately fine powder, 85 to 120 is fine powder, and 120 to 325 that is very fine powder. Again there is a mention, or they are also separated, they are also classified as per the nominal mesh aperture size. If you observe, the nominal mesh aperture size for sieve number 10 is 1700 micrometer, while sieve number 325 the nominal mesh aperture size is only 45 micrometer. As you observed, as sieve number increases, the nominal mesh aperture size will be decreases. So nominal mesh aperture size indicates as the distance between the two apertures, or the distance between the two wires, called as nominal mesh aperture size. While there are microfine powders is there, so a powder of which not less than 90% by weight of particles will pass through sieve with nominal mesh aperture of 45 micrometer. So those powder will pass from sieve number 325, or nominal mesh aperture size is 45 micron. That particle is called as microfine powder. While superfine powder is nothing but a powder of which not less than 90% by number of particles are less than 10 micrometer in size. If the particles will pass from that sieve having a nominal mesh aperture size is 10 micrometer, then that particle is called as superfine powders. So these are nothing but the again grades of official standard of sieves. Sieves are the simplest and sieving is the most frequent method used for size separation. Sieves for pharmaceutical testings are constructed from wire cloths with square meshes woven from the wires of brass, bronze, stainless steels or any other suitable material. Sieves are selected to cover the entire range of particle size present in test sample. The nest of sieves is assembled with the coarse screen at the top and the finest at the bottom. When we go for size separations with the help of sieves, so we arrange a set of sieves as per the ascending orders. Official standard of sieves. This table will indicate as the approximate sieve number, approximate percent sieving area, nominal mesh aperture size and tolerance average aperture size. So as per the sieve numbers, they are vary, which is mentioned in Indian Pharmacopoeia 2018, volume 1st, page number 22. Specifications. Sieves used for pharmaceutical testing must match the following specifications. First is sieve number. Sieve number indicates the number of meshes per linear length of 25.4 mm in size, or in another language it will denotes the number of holes or apertures or openings present in sieve within 1 inch length of the sieve mesh. How many number of apertures present in 1 inch, so that indicates as sieve number. Second, nominal mesh aperture. The nominal size of aperture indicates the distance between two adjacent wires. It represents the size of square aperture. As per Indian Pharmacopoeia 1996, it gives the nominal mesh aperture size for majority of sieves in millimeter or in micrometer. Nominal diameter of the wire. Wire mesh sieves are made from the wires having the specific diameter in order to give a suitable aperture size and sufficient strength to avoid the distortions of the sieves. Approximate percentage sieving area. It expresses the area of mesh as a percentage of total area of sieves. Generally, the sieving area is kept in the range of 35 to 40% in whole sieves. Next, the aperture tolerance aperture size. The variations in the aperture size is expressed as aperture tolerance average. Some variations in the aperture size is unavoidable. The variation is expressed as percentage and it is known as aperture tolerance average. Requirements. The sieves shall be devoid of defects and damage. Whenever we are utilizing the sieves, there are some characteristics of sieves. First, it should be devoid the defects and damage. The wires are of uniform circular cross sections. There must be no reactions between the material of sieves and the substances being sifted. Sieves may be calibrated optically to estimate the average opening size and opening variability. Perform the sieve analysis at control room temperature and at ambient relative humidity. Sieves should be cleaned using a low pressure at jet or a liquid stream. Official standard of sieves. Common standard used for sieves are Tyler Standard Scale, US standard proposed by National Bureau of Standards, British Standard Sieve Series, German DIN, IP Standard Sieve Series, International Test Sieve Series, etc. So the Tyler and US standard can be interchangeable since the difference between the two standards is less than allowable tolerance in viewing of the screen. These are also known as test sieves. Sieves used for pharmacopoeial testing must match some specifications like number of sieves, nominal mesh aperture, nominal diameter of wire, approximate percentage sieving area, and aperture tolerance average size. Different types of sieves. There are four types of sieves: woven wire sieves, bolting cloth sieves, bar screen, and punch plates. The primary consideration of sieves are to the size and shape of aperture openings. The square meshes are arranged as per the specification. In that first, the woven wire sieves. The wire woven sieves are general purpose sieves and most widely used in case of pharma fields. The types of woven wire sieves are plain views and twill views. The nature of sieve surface as shown in figure. For fine sieving, the metal wire woven sieves is used. Most common examples are hand sieves. These are included in roller mill, ball mill, etc. In case of coverage sieves, the wire is generally given in double cream to preserve the alignment of the wires. Second type, that is bolting cloth sieves. Silk, nylon, cotton, these are the generally woven from the twisted multi-standard fibers. Nylon cloths are generally designed by their micrometer opening and available in different grades. These are used for the separation of fine powders, or we can call it as dust powder, basically used in case of back filter. So Hummer screen is a example of this type of screen. Basically that cloth sieves are used in case of back separator for separation of dust particles. Third type of sieve is a bar screen. Bar screen are generally used in handling large and heavy pieces of materials. The bar are fixed in parallel position and held by crossbar and spacers. Bars which taper in thickness from one end to the other are recommended. Grizzlies use this type of screen. Another type of screen is punch plates, or we can call it as perforated screens. These are used for core sizing. The screen are prepared by using a metal sheet of very different thickness with perforated holes. The holes may be round, oval in shape, square or rectangular. This type of screen are used in case of hammer mill. Remaining part of size separations will covered in size separation part 2 section. Thank you so much.